Okay, now we want to talk about how are igneous rocks classified. So ultimately, you have to understand this chart here, which is going to classify the different types of igneous rocks. Okay, but in order to understand that chart, you got to know some different definitions. So that igneous rocks are classified based on their mineral content and their texture. So in this chart here, you've got the mineral content is going sideways. So those are the different minerals that are going to be located inside of those igneous rocks. Okay, then you have the different textures. And the textures are the things that are going up and down on the chart. So you notice it says pyroclastic, vesicular, okay? And that's going to be these definitions right here. So let's go through these different definitions. Pyroclastic means that it's going to be materials that are flying through the air. So these could be actual chunks of rock and fragments of rock. Vesicular means that it's got holes in it, and those holes are going to be formed by gas escaping from the magma. Then you have glassy. So glassy means it's made of glass, and it has no crystals because it cooled off so rapidly. Then you have aphanitic, which means that the crystals are there, it's just that you can't see them. So the crystals are so small that you can't see them. So an example of this is going to be rhyolite. Okay, then you also have definitions that go with igneous rocks that form inside the earth. So that means intrusive. Extrusive means rocks that form on the surface of the earth or in the air, whereas intrusive rocks form inside the earth. And so you can have, let's do phaneritic first. So phaneritic is the opposite of aphanitic. Aphanitic, you can't see the crystals because it cooled off so rapidly. Phaneritic crystals, you can see with the naked eye, and that means that they had a chance to form because these igneous rocks formed at depth inside the earth where they cooled slowly and the crystals had a chance to form. Okay, porphyritic is in between phaneritic and aphanitic. So in a porphyritic, what's going to happen is the material starts inside the earth, crystals begin to form. But then, for some reason, the magma gets shoved up to the surface, and so all of the other crystals did not have a chance to form. So that what you're going to see is it's mostly aphanitic with a bunch of small crystals embedded into it. And so it's kind of phaneritic and it's kind of aphanitic, it's kind of half and half. And then you have pegmatitic, which means that you have exceptionally large crystals that form from a liquid. All right, so if we were to look at this chart again, you'll notice that the pyroclastic types of rocks are up there at the top. Now, at the very top of the chart is the minerals that are in the rocks that are in the bottom part of the chart. So that anything that's in that very first column, those are going to be the felsic rocks. All right, felsic rocks means they've got lots of quartz in them, lots of silica. So you'll notice that quartz is very abundant in the felsic types of rocks. Also, so is the potassium plagioclase is also, potassium feldspar is also in there. So is the mica, and so is the biotite. So all of those kinds of minerals are very abundant in felsic rocks. But then when you go to the intermediate rocks, you'll notice not so much quartz anymore, But now notice that you're starting to get plagioclase, feldspar, and you're also starting to get more amphibole. And then if you go even further, you get into the mafic ones, where now it's pyroxene is the major mineral that's in there with some amphibole. And then finally, when you get over to the ultramafics, notice that olivine is the basic mineral in it. Now that should sound familiar. So you've got the felsic, intermediate, mafic, ultramafic, and notice that each of the different categories has different minerals in it. Well, that's the same as if we go back up to here. The only difference is that the chart has been turned on its side. So here you have the ultramafic at the top, and then the mafic, and then the intermediate, and then the felsic at the bottom. Whereas in this chart, they're side by side. But compare those two charts with each other, and you'll notice that they have the same mineral compositions. All right, now what were the textures? So you're going to have pyroclastic. So these are pieces of rock that fly through the air. And you'll notice that you can have pyroclastic felsic, intermediate, and mafic rocks. So all of those kinds of things can fly through the air. Why not the ultramafic? Because the ultramafic is way, way, way down inside the Earth in the asthenosphere. And the chances of that material coming up to the surface and exploding and flying through the air is very, very slim. So that's the reason why it's not really represented. Okay, then you have vesicular. So the vesicular is the one that has the gas holes in it. And so an example of that was going to be like scoria and also pumice. And notice that pumice tends to be a felsic rock. But notice that scoria tends to be a mafic rock. So that would be important to know for the exam. Then you have the other kinds of rocks. So you have the aphanitic, and you also have the phaneritic rocks, and how they are classified. All right, so let's go through some of the important rocks that you'll need to know for the exam. So you definitely got to know granite. So granite is what the continents are composed of. So granite is going to form inside the earth at depth, because notice you can see the crystals in granite. The same thing is true for the diorite, the gabbro, and then the periodotite. They're on the end. So all of those rocks are going to be phaneritic rocks because you can see crystals in them. Now on top of them, so the rhyolite is made of the exact same material as the granite. The difference is it forms at the surface of the earth, it cools off quickly, so the crystals are very small. Okay, andesite is made of exactly the same material as diorite. It's just that andesite forms at the surface of the earth. Basalt is made of exactly the same material as gabbro, but basalt forms at the surface of the earth. So basalt is very important because basalt is what the ocean floor is composed of. And then we said that underneath that was gabbro. So that makes sense. So at the surface, you've got the basalt. Underneath it, you got the gabbro. So some other igneous rocks that you need to know. Obsidian is glassy. Scoria was the one that was vesicular. It had the gas holes. Pumice is the one that will float in water. Okay, then you also have some of these pyroclastic materials such as tuff and volcanic breccia. And then lastly, that's an example of a pegmatite. a gigantic crystal. So look at the size of that crystal there. So it's about 12 feet long, or about 4 meters. So where do you find igneous rocks? So you're going to find them at mid-ocean ridges. So where stuff from the asthenosphere is coming up to the surface, and then it breaks the surface apart. This was a divergent zone. So where the plates are being pulled apart, this is where you're going to have your basalt and your gabbro. Okay, so remember, we start with the ultramafic materials, so that periodotite inside the asthenosphere. Initially, as it comes up, it changes chemical composition and becomes gabbro if it hardens inside the earth, or it becomes basalt when it comes up to the surface of the earth. And so again, that's where the ocean floor comes from. You can also have it where continents are being pulled apart. So where the continents are being pulled apart under a hotspot, for example, again, this ultramafic material comes up. Now, it's a little bit more difficult to predict what kind of rocks you're going to get, though, because sometimes it comes all the way up to the surface and it makes the basalt, just like in the middle of an ocean. But sometimes it mixes with other materials, and so it can also produce felsic rocks, such as granite. So it can be formed under these conditions. Okay, then you could also have it at subduction zones. So this was a divergent zone. Okay, here is a subduction zone. And so you're going to have a lot of mixing that occurs. So that you're going to have the mafic materials that make up the ocean plate. So mafic materials over here. And then you have the continental materials over here. So this is granite. The continents are composed of granite. The oceans are composed of basalt. So when they mix, so when it subducts, then this mafic material is going to intermix with the granitic material. That's what's going to make intermediate materials. So if we go back to here, so that the mafic materials was the basalt and the gabbro. The felsic was the rhyolite and the granite, and then when they mix together at a subduction zone, that's where you get your andesite and your diorite from. Okay, then you can also have underneath of hot spots. So that's another way of mixing these magmas together. Okay. So what are some types of igneous features? So these are going to be intrusive features, features that form inside the Earth. So another name for this is plutonic. Make sure that you know what the word plutonic means. So a plutonic rock is one that forms inside the Earth. And so you're going to have the original magma chamber, and if it's a really, really big magma chamber, that's going to be, when it hardens, it's going to turn into a batholith. And then, so let's say that here's the surface of the ground, here's the gigantic magma chamber, this thing hardens, and then it turns into a batholith. Okay, now erosion comes along, and erosion gets rid of all of this rock up here. So now it's eroding down to here, and now this hard thing is sticking up out of the ground, and so this is what a lot of the mountainous terrain in the Rocky Mountains are, is a lot of these batholiths that are sticking up out of the ground. Okay, you should also know what a dike is, and what a sill is, and what a laccolith is. So I will let you go back in your notes and look at what those features are, be able to identify a picture of them on the exam. Alright, so that is it for this review. So in our next review video, we're going to start talking about sediments and sedimentary rocks.